In this video, we're going to look at how to draw a line graph, and the question says, draw a graph of the mass of the wood on the y-axis against the volume of the water on the x-axis, and then we have a table of results. Now before we start, let's have a little look at some of the words that I might be using in this video. So first of all, the small squares are just the little tiny squares. The medium squares are 5 of those small squares together, 5 times 5 even, and then the big squares are 10 by 10. So as I count, I might be talking about small squares or big squares. So let's get started. Let's read the question carefully. Draw a graph of the mass of the wood on the y-axis. So that means the mass is on the y-axis. And I have 4 columns for mass. Mass 1, mass 2, mass 3, and then average mass. So when I'm plotting the graph, I'm going to plot the average mass. These values were just measured to help me find the average mass. So for plotting the graph's sake, we don't look at these results here. So our average mass will be on our y-axis. And then our volume is on the x-axis. Okay, let's get started. Let's have a little look at the x-axis first. So our results go from, our results go from 0 up to 100. So ideally, we would have one big square for 10. So let's have a little look and see if that fits in. So I'm going to start down. The x-axis is the one that goes along the bottom. So remember, you crawl before you climb, or you can say that y's up. But along the bottom is our x-axis. And we're going to start here with 0. I'm not going to write anything else in until I'm sure it works. So I have one big square, 2, 3, 4, 5, 6, 7, 8, 9 big squares. So if I went up in tens, it would be 10, 20, 30, 40, 50, 60, 70, 80, 90, and I wouldn't be able to fit the 100 in. So in physics, we like to use our scales to go up in either 2s, 5s or 10s, or multiples of 10 of those. So 20, 50, 100, 200, 500, 1000, etc, etc. So we can't go up in 10s, so let's try one smaller than that. Let's go up in 5s. So, one bigger than that. Let's go up in 20s. So 20, 40, 60, 80, 100. Now it's not going to use up all the page if I use this scale, but it is going to use more than half of the page, which is perfect. So let's just write down 0, 20, 40, 60, 80, 100. And then before I move on, I'm going to label the x-axis, and I just use the label that we've been given in the table. I copy it exactly. So volume / centimetres cubed. Okay, now let's have a look at the y-axis. So our y-axis is average mass in grams. Our smallest value is 0 and our biggest number is 51, and those are the only 2 numbers we're interested in when we're choosing our scale. So we have to go to a number that's bigger than 51. So it's either going to be, if we go up in multiples of 2s, 5s or 10s, it's either going to be 52, 55 or 60. Now let's have a little look at our count the number of big squares. So we've got 1, 2, hard to see, 3, 4, 5, 6, 7, 8. So if I go up in 2s, I'm going to 2, 4, 6, 8, 10, 12, 14. That's not going to be big enough. 5s, 5, 10, 15, 20, 15, 20, 25, 30, 35. Still not going to fit. Let's try 10s. 10, 20, 30, 40, 50, 60. So it's going to be bigger than 51. It's still going to use up more than half the page, so that's ideal. So let's label that 10, 20, 30, 40, 50, 70, 60. And then we'll use this label that's given to us in the table. So average mass in grams. Okay, let's start plotting some points. First point is 0, 0. So you use X's or dots with circles around them. The first one, our X value is 20 and our Y value is 10. So we're going to go along to 20 and then up to 10. So remember, you crawl before you climb. So I've done the first point and I've done the second point. Don't stroke out the actual values in case you need to check them. And now we're coming to our third point. So our volume is 40 and our mass is 19. So on this scale, every little square is worth 1. So let's go along to 40 and up to 19. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There we go. Take that point. We've got 60 and 32. So 60, then we've got up to 30, and every little square is worth 1. So 31, 32. Take that one off. Then we've got 80 and 39. So we go along to 80 and we go up to 30 and then we count up to 9. 31, 32, 33, 34, 35, 36, 37, 38, 39. Okay, take that point off. We've got 151. 100. Then we go up to 50 and then one more than that brings us to this point here. So now we have plotted all our points. It looks to be a nice straight line. There's a few that aren't exactly on the straight line, but that's okay because we're going to draw now a line of best fit. Now, if our graph passes through 0, 0 and our results table says 0, 0, then our graph has to start at 0. So what I'm going to do is put my ruler and put my pen at 0, 0 and use it like an anchor. And a good line of best fit will have approximately half the points above the line and half the points below the line. So right now this is not in a good position because all of the points are below the line. So let's move it round a little bit. And if I move it there, all of the points are above the line. So that's not good. So I need it to be somewhere in between. And if I choose somewhere about there, then I'll have a lot of the points on the line, one above and one below. Just turn around a wee bit there. And just make your line go the whole length of the graph. Like that. And that is a good line of best fit. So, if your scale was a little bit more complicated, where you had a scale that went up in 20s, or for example, let me just plot one more point. I think that might help. So let's say we had a volume of 24 and our mass for that was around 12. So this is when the scale's not on a 1-to-1. So if we look at our x-axis, every 10 squares is worth 20. So I'm just going to write that down on a piece of paper here. So on our x-axis, 10 squares is equal to 20. And that means that one square, to get from here to here, I have to divide it by 10. So to get from here to here, I also must divide by 10. So 1 square is equal to 2. So let's have a little look at this point. We need this extra point that we're going to plot. So the x value is 24, and on the x-axis, 1 square is equal to 2. So we go along to 20, and then we count in 2's for every little square. So 22, 24. Now I'm just going to check that I'm right. 24, 26, 28, 30, 32, 34, 36, 38, 40. So I know that I'm right because I've counted up to the next number. So 24, and then our y-axis is worth 12. So we go up to 10, and then remember on the y-axis, each little square is worth 1. So we go 11, 12, and our other extra point would be there. So that's just a little help if the scale is slightly more complicated than 1 to 1. Okay, I hope this video helps, and good luck.